Yeah, guys. We started with the linked list class in yesterday's session, right? We discussed about when to use array list and when to use linked list. Am I correct?
Yes, sir.
Guys, okay. Yeah, we'll start. So I told already in the last session that linked list contains nodes. Every element is stored like a node, and each node is containing uh, three parts like previous link, data, and the next link. And in a linked list, what happens? Adding and removal of elements is very easy, right? In a linked list, we can add the elements or we can remove the elements. But when you want to retrieve the elements, it's going to take time, right?
Yes.
Yeah. So that's why at the time when you have more times retrieval operation, then you have to go for what? You have to go for
And
array list. And suppose if you want to perform more times add delete operations, then go for what? Okay, then go for linked list. Now, as I told already, in linked list, the cursor can be moved from the either head node or from tail node. In the last, I told that you please draw the diagram for that, right? Head node will be there and the tail node will be there. So the cursor can be moved either from head node or from the tail node, correct? And let's see what are the other new methods that we have in linked list class. Okay, I mean to say that uh, in list interface we found some methods, correct? If you go to the diagram where we can find some methods of list interface, right? List interface contains methods. Collection interface provided methods. If you look at these methods, these are all the methods of list interface, which I can say that what these methods are, these methods can be used with linked list object also, because linked list is a class, implements what? List interface, right? And array list is a class which implements what? List interface, right? So these are the methods of what? Collection. So collection interface methods, next list interface methods, all we can use in array list class, and all methods we can also use with linked list object. But apart from that, linked list object also has additional methods. So now we are going to look at about what are the additional methods in the linked list class. Okay. So apart from the methods of collection interface and list interface, because for example, you take list. List is an interface extends collection, which means what? Collection interface methods are available to the list interface. Correct. Next, what? Linked list is a class implements list interface, which means all the list methods are available to linked list class, which is inherited to the linked list. Now, linked list class also has additional methods. Now we are discussing about what are the additional methods in the linked list class. Okay. So let's see how it's going to happen. So basically, question is now when to use array list class and when to use linked list class. In array list, when you are, it is a good fit when there is no need to when there is a need to retrieve the elements more times. When linked list is a good fit when there is a need to add or remove the elements more times, because adding and removal of elements is easy in linked list. Am I correct? But whereas retrieval is faster in array list, because in linked list, if I want to retrieve any element, the cursor is internally moved from either head node or from the tail node. So it can't directly go to node number 40. If I want to get the node 40, then what happens? So means node at the index 40, then the cursor is moved from head node to 40, or cursor will be moved from tail node to 40. Am I clear with that? So it will take some time. That's why retrieval is slow when linked list contains more elements. That's why when there is more times you want to perform the retrieval operation, then array list is a better option. And more times you want to perform adding new elements or removing the existing elements, then linked list is a better option. So to choose either array list class or linked list class based on the requirement. Okay, cool. This is I mean, what I can say, double linked list implementation of the list interface. Double linked list in the sense, the nodes are connected with each other in two ways. Means the first node connected to second node again connected to first node. This is called double linked list. In single linked list, what? First node connected to second node. That's it. Again, second node is not reversely connected to first node. That is called single linked list. But we are talking about what? Double linked list. Linked list in Java is a double linked list implementation. Double linked list implementation says that nodes are connected with each other in both the ways. Both the ways in the sense what? First node is connected with second node is connected again back to the first node. Okay, that is what I'm trying to say. Now we are going to look at the methods now. Let's see. Today we are going to start with the methods of linked list, and we'll see a small application with those methods, whether to check whether these methods are working properly or not. Okay, yeah. And then next we are going to look at about the other concepts, like how do we sort the elements of list. Okay, array list. How do we sort the elements of linked list? I'll tell you all those things. Okay, cool. Let's go ahead first. Guys, today I'm just going to talk about methods. Methods of linked list class. Okay, first I will open linked list class from the Java API, from the Java documentation. That's called API document. Okay, Java API documentation, where we can find some additional methods. So, okay, there are methods you can find like add first, add last, then something like get first, get last. We have some methods like that. Okay, remove first, remove last. Okay, you can find such kind of operations. I'm just going to show them. First, let's open Google. Let's type java.util.linked list. Working with the linked list. Observe here. Okay, right. One thing to say, guys, one thing to say that like array list, linked list does not contain initial capacity. Suppose if you take array list, what happens? Initial capacity will be 10, which means internally dynamic array is created with the size 10. But you know, in linked list, internally array is not created. Internally, what are created? Called nodes. Internally, nodes are created, correct? So what I'm saying now, array list has initially 10 as a default capacity. And whenever we add, for example, when the capacity is crossed, nothing but, for example, if I am adding the 11th element, then I said the size gets increased. Capacity will be incremented to 50%. It becomes 15. But in linked list, you don't have any such kind of capacity. Linked list can store any number of elements, unlimited. And we don't have any something called as capacity, or capacity gets doubled, or capacity will be incremented by 50%. We don't have such kind of things for linked list, because linked list doesn't store internally in a dynamic array. It is going to create a double linked list. That's why there is no capacity for linked list. Okay, right. So keep that point. Otherwise, I will also write. One thing I can write here is what? Initial capacity of array list is, okay, initial capacity of array list is 10. Okay, okay, that you know, initial capacity of array list is 10. But for linked list, okay, for linked list we don't have any capacity, or for linked list there is no capacity. There is no capacity. Okay, there is no capacity because linked list is not going to use, dynamic array. because linked list doesn't use array internally. Linked list doesn't use an array internally. Okay. Cool. Let's go ahead with the linked list class. Look at this. There are many things other discussed. We'll discuss one by one. See this add method of element, add of index. These are there. Actually, these methods are coming from collection to list to linked list. That's why I'm not writing these methods. But if you look at this method, add first method does not exist in linked array list class. You have add method. You can call add method. You can call add method with index and element, with parameters index and element. But you cannot call add first method on array list. Add first, add last. Okay. Get first, get last. Okay. Please understand. Now, okay. This is to add an element. Okay. At the last of the list. That's called offer. Okay. It returns Boolean if it is added. Okay. Offer. That's okay. Offer first, offer last. Okay, right? Offer first, offer last. Next, peak first, peak last. Poll first, poll last. Okay, right? Pop generally in stack we use it, but okay. Pop and push for adding the element, pushing the element. Pop is to remove the element. Okay, remove is there even in array list also. It's there in linked list also. And similarly, we have remove first, remove last. Okay, remove first, remove last. All the methods we wanted to discuss, but I'm just telling something like that. So tell me, there are some methods like first class like that. Add first, add last, remove first, remove last, get first, get last, poll first, poll last, peak first, peak last. Like that, you are having some, methods, right? Okay, this method does not exist in array list, but these methods exist in what? Linked list. These methods exist in linked list, but they are not exist in the array list class. So what's the point I want to write is, for example, if you take add first now, what this add first method will do? It will insert the specified element at the beginning of this list. At the beginning in the sense what? At the head node. At last means at the tail node. It is appends the specified element to the end of the list. End of the list is nothing but tail node. Right, okay. So add first is a method. Add last is a method. Add first method inserts the element at the beginning of the list. Add last appends the given element at the end of the list. Okay, right? So this is going to become the first element. This is going to become the last element. Okay. What is methods next? Get first, get last. Get first returns the first element. Get last returns the last element. Get first returns the first element. Get last returns the last element. Okay. Good. Observe here. I'll open this. Okay. Returns the first element of the list. Na? What if the list is empty? It will throw an exception. What's the exception? No such element exception. When? If this list is empty. Which method? Get first. Similarly, what about get last also? It returns the last element. But what happens if the list is empty? If the list is empty, what will be thrown? No such element exception. No such element exception. Okay, na? Right. Similarly, okay, I have shown you that point. Let's go here. Let's go with the add first. Right. See what add first method will do. This add first method inserts the specified element at the beginning of the list. Are you going to find any exception thrown by this add first method? No. Add last method will it throw any exception? No. But what about get first? Will throw an exception if the list is empty. If the linked list is empty, then what? No such element exception will be thrown. That's the difference. Okay, right. Next. Similarly, I'll tell you differences we need to identify. There is a method called offer. Offer first, offer last. Okay. First, we'll go with offer method. Adds the specified element as a tail, last element of the list. What add last also will do? What add last method will do? That will also add the element at the tail, last element. Am I right or not? But what is the return type of offer method? Boolean. What is the return type of add last method? Void. If you look at add last method, what is the return type of add last? Add last method return type is what? Void. Offer also will do the same thing. What offer method also will do? Will add the given element as the tail of this list. Tail means last element. But returns what? Boolean. Returns Boolean. Okay. Returns true if the element is added successfully, returns true. Otherwise returns false. So offer method, add last method almost works like same, but return type is different. If you take offer first, insert the specified element at the front of the list. Front of the list means head. Return type is what? True. Add last, insert the specified element at the end of the list. This is called what? Return type is Boolean. So add first, add last, offer first, offer last, almost looking same, but the return types are different. Add first, add last return types are void. Offer first and offer last method return types are Boolean. Let's see. We will discuss, how this is going to work. Okay, next. Let's go ahead with the other methods. All the methods I will write. Next. This peek we'll discuss. Peek method will retrieve the element but doesn't remove. Okay, I repeat once again. Okay, peek first, peek last. We'll see what this peek method will do. Okay, what this peek first method will do? Retrieves but does not remove the first element of the list. If, for example, list is empty, returns what? Null. Peek means retrieving. Which element? Peek first means first element. Peek last means last element. What in case if your linked list is empty? It returns null, but doesn't throw any exception. That's called peek first and peek last. Similarly, I'll show you poll first, poll last. You can see the difference. Okay. What's the method here? Poll first. Retrieves and removes the element of the list. See, what peek will do? Only retrieves, but does not remove. But poll retrieves and removes that element also. And returns null if the list is empty. So what's the difference between peek method and poll method? Peek only retrieves but does not remove the element. Poll will retrieve the element as well as it will remove the element also. And both the methods, if the list is empty, returns what? Null. Yeah. Guys, folks in online, are you understanding what I'm trying to say? Did you get my point? Did everyone?
Yes, sir.
Did you got the point, right? Okay, let's go ahead, guys. I will write all these methods, then we'll start writing some code for that. Okay, that's called poll first and poll last. But there is something called as remove first, remove last also. I will delete these two. You can see here. There is a method called what? Remove first. You can see what remove first method will do. Removes and returns the first element. Means retrieves and removes. But it is going to throw what? Exception if the list is empty. So what is the difference between peek and pull? Peek method will retrieve the element but doesn't remove. And if the list is empty, returns null. Poll method, it will retrieve and remove the element and returns null if the list is empty. But remove first, it will remove the first element. Remove last will remove the last element. But if the list is empty, throws exception. Which exception? No such element exception. No such element exception. So like this, you have methods called what? Add first, add last. Peek first, peek last. Poll first, poll last. Next, remove first, remove last. Offer first, offer last. Offer and add both are same, but return types are different. These are the methods of additional methods in linked list class. These methods we cannot use with array list class because in array list we don't have any head node and tail node to add at the first place or to add at the last place, or to remove from the first place or to remove from the last place, right? To retrieve from the first place or to retrieve from the last place. We don't have any such kind of head node and tail node in array list, but we have them in linked list. Okay. So guys, let me give you methods now. Let's start with one by one method. First method, add first. Add first of element. Okay. Add first of element. Tell me what add first of element. E means element, na? What add first method will do? Inserts the element at the head of the linked list. At the head place means first place, na? Inserts the element at the head point. We know that linked list contains head point and tail point. Head node, tail node. Head point means first element. Tail node means last element. Okay, at head point. Add last. But what is the return type of them? What is the return type of them? Boolean. Appends the element at the tail node. Tail point or tail node. Tail point, head point. Next. Offer is okay, not required. Next one is get first. What this will return? Returns the element at head point. But what happens if the list is empty? Throws which exception? No such element exception. No such element exception if the list is empty. Next, fourth method. The fourth method, get last. What it will do? It returns the element at the tail point. Again, same statement. What? Throws which exception? No such element exception if the list is empty. If the list is empty. Now, did everybody understood about this? Okay, guys. Am I clear? Okay. Add first is a method. Next one, add last. Similarly, next what? Get first, get last. These are the methods, na? Similarly, next what's the other method that we know? Poll first, peek first is there. Peek first. Tell me what peek first will do. Returns the element from the head point. Okay. Tell me what if in case, for example, if the list is empty, will it remove the element? Peek first will remove the element or only returns the element? Returns but not remove. Okay, returns but not remove the element. From the which point? Returns but not remove. The element from the which point? from head point. Okay, right. Returns null if the list is empty. If the list is empty, then returns null. Tell me what's the next. Similarly, peak last. So identify the difference. That's it. Who is returning only? Who is not removing? Returns but not remove the element. Okay, the element from the tail point. Okay. Okay. From the tail point. Same. If the list is empty, then what? Returns what? Null. Returns what? Null. This is how the method works. But the next method works poll first. POLL. What poll first method will do? Returns and removes. No, returns means retrieving only. Returns and removes the element from the head point. What in case if? Okay, what in case if the list is empty? If the list is empty, then returns null. What is the next method? Poll last. POLL. Poll last. Returns and what? Removes which element? The element from head pointer, tail pointer, tail point. Returns and removes the element from the tail pointer. What if the list is empty? If the list is empty, then throws, returns null. It doesn't throw any exception, right? Right. Remove first method is there, na? That will throw exception. What remove first will do? Remove first removes. See, that of course at one time you may not understand all these things, but okay. What remove first will do? Removes and returns the first element. But it will throw what? Exception. When if the list is empty. What I say is removes and returns the first element. First element means head point, na? Right. Throws what? No such element exception. No such element exception when if the list is empty. Last method I'm writing. What's the next method? Remove last. What happened? Okay. Remove last. Okay. What this method will do? Removes and returns the which element? Last element. Again same, throws no such element exception. No such element exception when if the list is empty. Okay, enough now. What are these now? These are the additional methods of which class? Linked list class, which means these methods we have, we don't have these methods in array list class, but these methods we can use with linked list. Linked list. Okay, add first, add last. Do you have these methods in array list? No, but these methods we have in linked list. Okay, because linked list contains two pointers, head pointer, tail pointer. Head pointer is at the first element. Tail pointer is at the last element. So we can add the element from the head place, or we can also add the element from the tail place. Otherwise, we can remove the element from the head place. Otherwise, we can remove the element from the tail place. We can also remove from a given index. These are common. See, as I already told you, as I already told you, that the methods of list interface can also be used with linked list, because linked list is a class implements what? Linked list class implements list interface, which means what? List interface methods can be used with linked list also. Plus linked list also contains additional methods. So what are these 10? These are additional methods. Apart from existing methods of list interface, these are new methods, additional methods. These additional methods we cannot use in array list object, or we cannot use with array list object, but we can use with linked list object. What about common methods like iterator, list iterator, add, remove,
Yes. It means
contains, clear, size? We discuss some methods now. What about these methods? These are commonly, these are list interface methods. List interface methods can be used with array list object as well as with linked list object also. These are common for all. Okay. How can you retrieve one by one element of a list of a linked list object? How can you retrieve the elements from linked list? I told already array list is there. How do you retrieve the elements from array list? How can you retrieve the elements from array list object? There are 3 ways I told. One is you can use for each loop. Second one, you can use iterator. Third one, you can use list iterator. What about linked list also? Same 3 ways. What are the 3 ways of accessing the elements of a linked list or retrieving the elements of linked list? Same for each loop. Iterator, list iterator. Means iterator, list iterator, these are common for array list as well as linked list.
Linked
Right.
list.
But what are these 10? These are additional methods.
Additional methods.
Additional methods for linked list object. These methods can be called with linked list object, but these methods cannot be called with array list object. Okay. Cool. Okay, I will start and write. See, let's write, let's see some of the methods, whether how they are working. I just want to create one linked list of integers. Let's see how the peak first is returning, what pole first is returning. We will understand. Okay. So let me create one small code for that. It is a linked list demo. It is a linked list demo program. Okay, now guys, it is a linked list demo program. So let's go with a new, then we can say what? Class, some package name I can enter, com.ashokit.cf. Class name is linked list test. We'll create a main method. Here in main only I'll write the code. See, first I want to create. Okay, first I want to create what I can say. First I want to create linked list object. Okay, just a minute. Okay, guys, I will start. I'll start now. So there is a class called linked list test. Now we'll start with the public static void main. I want to create linked list. Okay, I want to create linked list of integer. Okay, linked LST is equal to new linked list of integer. I told, but type parameter at the right side of object creation, that is optional. Of course, I'm writing now, but if you want to, you can write. Otherwise, you can remove it. Next, linked LST dot add of elements. For example, I'm adding 10. Linked LST dot add of 20. linked LST dot add of 30. Linked LST dot add of 40. Last element I'm adding first. Linked LST dot add of 50. Tell me what are the elements in linked list currently? 10, 20, 30, 40, 50. How many elements are there? 5. 5.
5.
5. Okay. Please understand here. I want to write like this now. System dot out dot println, or I can say, first I'll take one string variable, string line separator equal to dot repeat of 50. Okay, 50 or 60 something. Now I can start. First I want to print a size of the list. Tell me how can I find the number of elements in this list object? How can I find the number of elements in this list object, whether this list is having 5 elements or 10 elements or 15 elements? How can I know? How can I find the size? Yeah. Okay. There is a method called what? Size. Size is a common method. Size method we can use in array list, or we can use it linked list, or even in set or queue also, because it's a method from collection interface. Okay. Size is a collection interface method. It can be used with a list. It can be used with a set, or it can be used with a queue object. Okay, na? Right. So first I want to tell you guys, okay, understand what I'm trying to say. System.out.println, system.out.println, the size of the linked list. Tell me how to display the size of the linked list. What is the object name?
Linked list.
Linked LST dot which method I'm calling? Size.
Size.
That's a way of displaying it. Then I want to give separator. Line separator. Okay, that's okay. This is initially. Now let's do one thing. I want to say linked LST dot add first. Which method I'm calling? Add first. Add first of 70. Linked LST dot add first. Add last of 60. Tell me 70 is added which place? 60 is added which place? 70 is added at the head point. 60 is added the tail point. Tail point. Now, can you tell me how many elements are there in my list now? 7 elements. 5 plus 2.
7.
7 elements. Okay. System.out.println, the size of the linked list after adding at first and last. Linked LST dot size. Am I clear now? Am I clear now? Correct.
Yes, sir.
Correct. Okay. Good. Next. System.out.println. I'll use separator, line separator. Am I clear? Line separator. Next. System.out.println. Please understand the first element. Okay. The first element of the linked list. How can I retrieve the first element without removal? I want to retrieve, but I don't want to remove. Which method I have to use? Is it a peek method or poll method or remove method? Peek method. Peek method will only retrieve but does not remove. Poll method will retrieve and remove. Remove method will also retrieve and remove but it will throw exception also if the list is empty. That's a difference between peek, poll, and remove. Okay, what's the first element of the linked list? How can I display the first element of the list? Linked LST dot peek first. So how can I display the last element? How can I display the last element? The last element of the linked list. How can I display the last element? Linked LST dot peek last. Guys, am I clear with this? So first let us run the program up to this. Let's see the output now. First of all, tell me what's the size of the linked list initially? 5.
5.
5. Size of the list initially is 5. Size of the linked list after adding the first and last element is how much? 7. 7. Who is the first element in the linked list? 70. Who is the last element? 60. Because I called add first method with how much value? 70, integer 70. Add last method integer 60. Who is the first element now? 70, not a 10. Not a 10, 70. Who is the last element? Not 50. 60. That's why I'm getting output what? 70 and 60. But peek method will remove the element or only returns the element? Only returns the element, but does not remove. Does not remove. Observe here. I'll do one thing. Again, line separator. System.out.println line separator. Okay. Now, what poll method will do? It will return the element and remove the element. For example, I'll write. For example, I'll call like this now. Okay, I don't want to store it. See, linked LST dot poll first. Tell me what this method will do. It will return the element, but I don't want that element. And it removes also, no?
Yes.
Yes. Similarly, linked LST dot poll last. What this method will do? Will return and remove the last element. Am I clear? Okay. Now, after this, again, I want to call these two statements. Tell me the first element of the linked list after poll. After poll first. The first element of the last element of the linked list after poll last. Tell me how to retrieve the first element and how to retrieve the last element. What are the methods I have to call without removing?
Peek first,
Peek first,
peek last.
Tell me what is the output you are expecting for the last two SOP statements?
10 and 15.
10 and 50. Correct answer. 10 and 50. Why? Why 10 and 50 is our answer? Because
it's become a first.
See, poll first means 70 is removed. Poll last means 60 is removed. If a 70 is removed, who is going to become the head now? 10. If a 60 is removed, who is going to become the last tail now? 50. Yes, correct answer. Correct answer. Let's see. Now, this is the answer. Tell me now, after polling, who is the first? 10. Who is the last?
10.
50. Actually, who is the first? 70. After
70.
adding. And after adding at the last, who is the last? 60.
60.
But both are removed, no? So which
Yes.
method I called to remove them? Which
Poll
method
first.
I called to remove them?
First, poll last.
Poll first and
Poll first and poll last.
okay. Like this you try. Now I just want to write iterator to display the elements, all the elements, 10 to 50, right? So system.out.println the elements in linked list. I just want to display all the elements. Okay, the elements in linked list. I can use iterator, I can use for loop, which is called for each loop, or I can go with list iterator. Anyone I can use, but I am going with for each. Houted for each for data type. What is the data type of the element? What type of elements this list is having? Integer. So data type is integer. I colon collection object. Who's the collection object? Linked list object. System dot out dot println. Instead of writing println, I want to say print simply, because I don't want to print line by line, but I want to print in the same line. Print of I, then give some space between one element to the other element, so that you can see all the elements in the same line. Am I clear with this?
Sir,
Yeah.
is it okay instead of typing out integer if we put int?
You want to write int here?
Yeah, is it still going to work?
Yeah, it works. Because
Okay.
because reason I'll tell you. Okay, in Java there is a concept called as auto boxing. So the system will take care of converting int to integer or integer to int. Integer is a class. Okay, int is a data type. Integer is a class. For class we have an object. For data type we have a variable. But who will take care of automatically converting as per the requirement integer to int or into to integer? That will be taken care by Java. You don't worry. That's called auto boxing. It's a feature name called auto boxing. You can add int also, no problem. You can get.
All right, thank you.
Okay, you can see there I have written int I, right? Okay, at line 36, but you don't have any error. Right? We can write, no issue. Now you write you see output also, right? Good. So what are the elements now? 10, 20, 30, 40, and 50. Am I clear? These are the elements we have now. Actually, I added 70, added 60. After that, I removed 70 and 60 because I called methods called poll first, poll last. That's why again, what are my elements? 10, 20, 30, 40, and 50. Okay. Am I good? Am I good with this code now? Right. I can write int here. Otherwise, I can also write integer. Who takes care of conversions and all? Java. Don't worry. Right? Let's go ahead. So we are getting the same output. This is the a sample program that you people can practice to see how the peak first, peak last, poll first, poll last, add first, add last, these methods are working. So here, let me type the comment. The comment is in the below code. Is to test some of the above methods. Right? So you got some code here. Let's decrease the font size. Okay, so please go through this code and try to execute the program and see the output. Okay, see the output. Once you execute the program, check the output. Good. Now, there are two classes we discussed which are related. What are the two classes that we have discussed? One is called
Array list and
array
list.
list class, and second one is called linked list class. There is one more class is also there which is called a vector. I'll tell you. Because for a vector, we no need of discussing any much thing because I'll tell you the reason. Okay, there are same questions now. Okay, better. I'll also copy the same questions. We have discussed about some questions yesterday, right? These 4 questions are there. I'll copy the 4 questions. The same 4 questions are applicable even for what also? Linked list. But instead of writing array list, what I want to write? Linked list. Linked list. linked list, linked list, linked list. Okay, let's start. What's the first question? What the first question is? Linked list object is thread safe? Answer is no. Can we make linked list object as thread safe? Yes. How can we make it? We can call same synchronized list method of which class? Collections class. Same answer. Same answer. Okay. For example, just for your information, right? Linked LST. Who is linked LST? Identify that it is a linked list object. That's it. For the same method, what's the method name? Synchronized list method of which class? Collections class. Okay. Now, linked list object is mutable or immutable?
Mutable.
Mutable. Can we make linked list object as immutable? Yes. How? We can call unmodifiable list. Same. These are common methods or common questions for what and what?
Linked
Array
list
list object and linked list object. Am I clear with this? The 4 questions we are done. Next. Yesterday I have explained. That's why today I just want to copy paste. Same methods. Unmodifiable list, synchronized list, same methods of collections class. But only the object what you are passing, that is a different object. Yesterday we discussed here what we are passing there, array list object. Today we are passing linked list object. That's it. That's the only difference. The object which you are passing as a parameter, that is a different. That object is different, but the method is same. The method is same. Sure. Now let's go to the. I want to open 2 classes here. One is called java.util.arraylist. In one tab, java.util.vector. Because I told already as per our diagram, who is vector? Vector is a class. ArrayList, linked list is also. All these are the 3 classes or implementation classes. Implementations of which interface? List interface. Am I right or not? Okay. Are the 3 implementations of list interface. So this is ArrayList. Just you see the methods of the ArrayList here. Now this is vector. Okay, vector. Understand? Okay. These are the methods. If you look at the vector and ArrayList, both classes have exactly the same methods. For example, ArrayList is there. Add all, clear, clone, contains, ensure, capacity, for each, get, index of, is empty. How to check whether list is empty or not? Is empty. Is empty returns Boolean value, that true or false. True means what? List is empty. List is empty. Empty in the sense there are no elements. Okay. Remove method, something up to array, trim to size, something. Take a look at about the vector. Clear, ensure capacity. Okay, first element, last element. Okay, equals, get, iterator, is empty, blah blah blah, remove. Okay, and also you can find out size, to array, trim to size, etc. Means what and what are almost equal? Array list class and vector, but there is a difference. What's the difference? Vector is a synchronized class. What does it mean is vector object is by default thread safe. What about array list object? Okay. I think you are getting my point, guys. Please try to understand me now. Okay. So what's the difference between vector and array list now? Yeah. Okay. What is the difference between vector and array list now? vector object is a thread safe object. Array list object is not a
Non-thread
thread safe
safe.
object. Okay, not a thread safe object, which means what? If for example, two threads are simultaneously using the vector object, then it will allow both the threads to modify the elements at a time. Will it allow both the threads to modify the elements at a time? No.
No.
No. No. Are you getting my point, guys? No.
Yes.
How many threads it will allow at a time to modify?
One
thread. After one thread has done the work, then other thread can do the work. But both the
Yes.
threads cannot do the work simultaneously. Did you get my point?
Yes.
So this is called what? Thread safe. Okay. Who is thread safe object? Who is
Vector.
thread safe object? Vector. Vector is a thread safe
Thread
object. But what about what I can say? Array list.
Not a
What
thread
about
safe.
no, not a thread safe. So array list object is not a thread safe object, but vector object is a
Thread safe.
thread safe object. That's the difference between vector and
Array
array
list.
list. Array list. Remaining all same. Remaining as it is. Remaining as it is. Okay. Are you getting the point now? Right? That is the only difference between what and what. Yeah. What is the meaning of it now?
Array list is
Array list is a
not
not a thread safe
synchronized-
object, but vector is a thread
synchronized
safe
and
object. That's the
thread
only difference between what and what. Vector class and
safe. Array list.
array list class. Otherwise,
Array
both
list
are same.
class.
That's why we don't use vector class manually. Okay, we don't use vector. Only we use what? Array list. Because
Array list.
reason is, if I use vector, then application, because synchronized objects will decrease the performance of an application. Of course, you'll understand what is synchronization and all in multi-threading. That's why mostly we use array list only, but we don't use vector. Vector we don't use in real time. Only we use array list. In every real-time application, everybody is going to use array list object, but not vector object. Okay. Because if I use vector object, because of its synchronization behavior, it will decrease the performance of the application. It is thread safe object, nice. That feature is good, but it decreases performance. That's why
Array list is fast.
array list object is used mostly than vector. Vector is not used anywhere. In place of vector, we always use array list object. Okay, good. And even vector also having a child class which is called stack. Child class means derived class, na? So what is the child class of vector? Stack.
Just
Stack. Because stack is a class extends. Stack is a class extends vector. Stack class represents what? Last in, first out, LIFO, stack of objects. Okay, it extends which class? Vector.
Vector.
With how many operations? 5 operations. Okay, let's see what are the 5 operations. First one is what? Empty. Test if the stack is empty. Peek means looks at the object on top of the stack. Pop removes object at the top of the stack. Push means push an item to the top of the stack. Because last in first out means how it is going to work. Last in first out means how it is going to work.
Pop and push.
The elements are added and removed from the top place. So stack, you have to understand stack like this. Stack you have to understand in this way. You have to understand the stack like this. Stack you have to understand like this. Okay, stack you have to understand like this. Okay. This is the stack. This is a stack. Okay. For example, I'm adding element. To add the element, what we have? Push. Okay. Initially, the stack is empty now. But if I write, for example, stack dot push of There is no add method. What we have? Push. Stack dot push of 10. Then 10 will be pushed into the stack. 10 will be pushed into the stack. And there is a cursor which is maintained. That cursor name is called top, T-O-P. Top cursor is maintained. This is called what object? Stack. For example, if I write stack dot push of 30. Push of 30. Then tell me where this 30 is pushed. On top of the stack. Where is top? Top is above the first element. What is the element added here? 30. 30. Sorry. 30. Tell me now where is top? Now the top is moved. Top is moved to above element. Above place. This is top. Okay. Tell me always element is added at top. Element is removed from top. Okay. For example, if I say stack dot add of push of some element 50. Tell me now at this top what is pushed? 50. Totally how many elements pushed? 3 elements are pushed. There are 3 elements pushed. 10, 30 and 50. And now these are top. Of course, I have to increase it. Okay, no problem. But there is a top here. There is a top pointer. Okay, cool. Who is the last element? Who is the last element into the stack? This is one stack now. Right? Well, who is the last element inserted in the stack? 50. If I say stack dot pop, P-O-P. Pop means remove. But from where the element is removed? It is not removed from the bottom. Element is pushed or element is pop out from the top place.
Top.
Okay. Tell me who is the first element? Who is the first element in the stack?
50.
50. So pop means which element is removed? 50.
50 is
Who is the last element added into the stack?
50.
Who is the last element? Last element added, not first element. First which element added? 10. After that 30. After that 50. What is the last element? What is the last element pushed in the stack? 50. And who is the first element coming out of the stack?
10.
50. 50. 50
Pop.
only.
50 only. Pop means it is removing from top only, na? 50.
Yes.
This
Last
is
in,
called,
first out.
that is called last in, first out. That is called
Last.
last in, first out. Who is the last in element?
50.
50.
50. Who is the first out element also?
50. Yes.
This is called
Last in.
last in, first out. What are the methods? What are the methods of the stack class?
Push.
Push and pop.
And pop. And how to check the stack is empty or not? Empty. No, just empty. Empty. Okay. Yeah. Everybody getting my point? Right. Peek means what? You know peek already? Peek means only retrieves from where?
The top of the stack.
Top. No, it is not first head or tail. It is not a linked list. It is a stack. Stack contains only one pointer, which is top. So peek will only retrieve the element from top place, but does not remove. But pop,
It removes the object.
it will remove. Pop, what it will do? It will
Remove.
return and
Top
remove
element.
from where? Top.
Top.
Push means push means pushing the element, adding the element to where?
To the top.
At the top. At
Top.
the top. Search is to search for the object. Are you getting my point? Okay.
Yes,
But
sir.
while searching, it is one based position. One base in the sense what? Normally, if you take array, index starts with 0, na? But in stack, index starts at 1. For example, my element is at third place. In the stack, my element, whatever I'm searching, is at third place. Answer is 3. Third place means 3, na? But in case of arrays, it is what? 2. Because array index starts with 0, but stack index starts with 1. That's called one base, not 0 base. It is one based position. So tell me what are the 1, 2, 3, 4, 5 operations? Empty, peek, pop, push, and search. Okay. So what's the only one difference between vector and array list? What's the only one difference between vector and array list? Vector and array list both are similar classes, but only the difference is
One
vector
is synchronized or one is not
vector
synchronized.
object is a synchronized object and array list object is not a
Not
synchronized
a
object.
In vector, there is
That's-
a fast concept.
That's why we are not going to write any program on vector, but we can write the program on stack, because in stack what is the principle that stack follows? What is the principle that stack is following? You can see the stack class represents last
Vector.
in first out stack of objects. LIFO, last in first out stack of objects. It extends which class? Vector. With how many operations? 5 operations. What are the 5 operations? Empty, peek, pop, push, and search. Did you get all the points now, right? Okay. So push is to add the element at the top. Pop is to remove the element from the top.
From the top.
Okay, right? Empty is to check the stack empty or not. Peek is only for retrieving the top element, but not for removing it. Pop will remove, but peek will only retrieve. And search is to search for the element in the stack. And the element search is not 0 based index, it is 1 based index, 1 based position or 0 based position. That's the difference. Okay, let me first write like a question. That's better. Here only I'm adding, which means we no need to discuss about vector separately. Just a question is enough. Anyhow, we don't use that anywhere. So what's the question I want to discuss?
Fail safe.
That will fail fast, fail safe iterators will come when I'm talking about a concept of map. Okay, concurrent hash map concept is there. At that time, I'll explain combinedly for all, for list, set, for map combinedly. There is a concept called as fail safe iterator and fail fast iterator. Okay, na? Because you should know about a concept called as concurrent modification. Okay.
Okay.
Okay. Question. That's very important question even in interview. That definitely will get. Okay. I'll explain that later. Now, what's the difference? What's the question? What is the difference between
Linked list and array list.
array list and vector? What's the answer?
Vector is thread safe.
Vector is synchronized and array list is not.
Not a synchronous. Okay. Yeah.
And array list is fast and vector is.
Okay.
not
That
fast.
because of synchronization only, na? So just one difference is enough to write. What's the difference? Array list is
It's
not a,
thread safe.
or array list
Thread
object
safe.
is not anything. Array list object is not a
Thread safe object.
thread safe object. We can make it, but by default is not a thread safe now. So array list object is not a thread safe object, but
Vector.
vector object is a thread safe object. Okay, vector object is a
Thread safe.
thread safe object. Okay. Apart from that, almost all the operations of array list and vector both are same.
Same.
Both are same. And if I want to show that vector object is thread safe, we need to apply multi-threading. But as of now, we don't discuss anything on multi-threading. That's why without multi-threading, suppose if I directed a program on vector also, there is nothing. It looks like what program only? Array list only. Right? We will see if possible. I feel I don't explain that because it's not required. Vector we don't use anywhere. We use only array list. Okay. What is the other class? Who is a subclass of vector? Stack. Okay. Stack is a subclass or child class of vector.
Vector.
Okay, vector. So because there is push pop operations, I just want to write some statements and example related to what? Stack.
Stack.
So which means which class I'm going to explain now?
Stack.
Stack class. Okay. First point.
Stack uses LIFO. Last in, first out.
First of all, stack is a child class of which class? Vector.
Vector.
So I want to write the statement first.
Okay.
So stack is a child class of.
Vector.
So stack is a child class of. Is a child class of vector. Is a child class of vector class. Okay. So what stack represents? Stack represents last in, first out. Stack represents last in, first out stack of objects. Last in, first out stack of objects. Okay. You know what a stack maintains? A top pointer. Elements are pushed or elements are popped from the one place only. Which place? Top of the stack. Right? So stack maintains a top pointer. Pointer, I mean, we can say a top place, anything. Stack maintains a top pointer where the elements are pushed into the stack. Am I clear? Elements are pushed into the stack or popped out from the stack. Okay. From which pointer only? From the top pointer only. Okay. Top pointer. Pushing is from top. Popping is also from top only. From one place only. That is called stack. Okay. And what are the methods that are there in stack? The methods, directly I'm writing here, the methods of a stack class. Are
Empty.
only only 5 methods now. What's the first method? Empty.
Push, pop.
Yeah, empty. What's the next one?
Peak, push, pop.
Okay, push is there. Push of element, you can push the element. Next,
Yes.
pop is there.
Pop.
Pop is to remove. Peek
Peek.
is to remove or only to retrieve.
Only retrieve.
Only retrieve, but does not remove. That's called peek. Next one is search.
Search.
You can search for the object or element, whatever it is.
Yes.
But while searching, it is going to search for 0 based or 1 based. It is going to be 1 based. Okay, that's for session today. I will share these notes with you because I think I didn't share these notes. Okay, the collections notes I'm sharing now. The collections notes I'm sharing now. This is what is that I gave. Okay, I'm writing CJ. I'm just sharing with the today's date. Okay, 8th August. Done. Okay. The notes is shared with you. Please go through the notes and we'll continue on tomorrow. We'll continue on tomorrow. Okay, with the stack program and other sorting the elements of list and all. Okay.
Okay, thank you, sir.